Welcome to the lecture Interfacing of Relay, Buzzer and PIR Sensor with 8051 Microcontroller. Relay is an electromagnetic switch which generally used in industry and houses to control the different machine and appliances like a lamp, water pump, road light, AC compressor, etc. These are the devices which allow low power circuit to switch a relatively high current or voltage on or off. It is a combination of mechanical switch and an electromagnet. It prefers when we want to control a device or machine using the low strength signal. Now let us understand how this relay works. So it works on the basics of electromagnetic force. Internally, relay consists of a wire. This wire is wrapped on the soft iron core. When we apply a voltage between the ends of this coil, then there is a current flow through this coil. Due to this current, a magnetic field will be generated and attract the switch from NC, that is normally closed, to normally open. So whenever this coil is energized, this switch will be connected to normally open. So this switch is normally a connect switch or normally closed switch. So whenever coil will be energized, it will switch to normally open. If switch is initially normally open switch or a normally open relay, then after energizing this coil, it will switch to normally closed contact. Generally, relay coils are designed to operate from a particular voltage. It may be 5 volt or 12 volt. Also, relays of various current ratings are available in market. Now, this is the interfacing diagram of relay with 8051. It is used to connect this bulb to 230 volt supply when relay turns on. So, this is the relay. Through this relay, we are connecting this bulb to 230 volt supply. So when relay will be energized, this switch will be closed and current will flow through this lamp and this bulb will glow. So to drive this relay, we are using here transistor BC548. The relay driver function is to provide the necessary current. It is typically 25 to 70 milliampere to energize the relay coil. This is 8051 and in this diagram the relay or this transistor is connected to port terminal P2.0. So when this port terminal will be at logic 1, this transistor enters into a saturation and current will flow through this relay coil, and when this relay coil is energized, this switch will be closed and bulb will turn on. When we'll transmit a logic 0, this transistor will turn off. No current will flow through this relay coil. Relay coil will not be energized. So the switch will be open and this bulb will be switched off. A diode is connected across the relay coil. This is used so as to protect the transistor from damage due to the back EMF generated in the relay's inductive coil when transistor is turned off. When transistor is switched off, the energy stored in the inductor is dissipated through the diode and internal resistance of the relay coil. Normally, 1N4148 diode can be used as it is fast switching diode with a maximum forward current of 300 milliampere. This diode is also called as freewheeling diode. Now here external pull-up resistor R1 of value 4.7K is connected. The microcontroller have internal pull-up resistors. Hence, when a port pin is high, the output current flows through this internal pull-up resistor. 8051 have an internal pull-up of 10 kilo ohm. Hence, the maximum output current will be 5 volt divided by 10K, that is 0.5 milliampere. But this current is not sufficient to drive the transistor into saturation and turns the relay on. Hence, an external pull-up resistor R1 of 4.7 kilo ohm is used. So, this pull-up resistor will provide a sufficient current to this transistor, and transistor will drive into saturation and can energize this relay coil. So let us write an assembly language program to interface this relay. We'll write a program at this address 0000H. So we'll use assembler directive org. Then we'll clear this terminal P2.0. So initially transistor will be turned off. Since it is off, the relay coil is not energized and bulb is switched off. Now whenever we want to turn this bulb on, we'll send logic 1 to transistor. So transistor enter into saturation region, current will flow through relay coil and relay will close the switch. So bulb will be connected to 230 volt supply and it will turn on. We'll keep this bulb on for some delay and then we'll turn this bulb off. So this is the simple program to turn on and turn off the relay. The delay program we can write, here registers are used. We can write a delay program using timer also. Now interfacing of buzzer with 8051 microcontroller. Now buzzer is an electronic device that converts electronic signal into buzzing noise. As an example, this is the number of one type of buzzer, that is ABI 009RC. It has two terminals, one terminal is positive and other is negative. These are the features of this buzzer. It is black in color, have internal driver circuit, sealed structure, wave solderable and washable, housing material, that is noise. It has many different applications. Few applications are listed here, like it is used in computer and peripherals, communication equipment, portable equipment, automobile electronics, POS system, electronic cash register. So these are the few applications of where we can use this buzzer. The specification of one typical buzzer is rated voltage 6 volt, operating voltage 4 to 8 volt DC, rated current is less than or equal to 30 milliampere, sound output at 10 centimeter is greater than or equal to 85 dB, resonant frequency is 2300 plus minus 300 Hz, tone is continuous, and operating temperature is minus 25 degrees centigrade to plus 80 degrees centigrade. Storage temperature minus 30 degree to plus 85 degree. Weight is 2 gram, and these all values are at rated DC voltage. This is the interfacing diagram of buzzer with 8051 microcontroller. So here reset circuit is shown, crystal circuit is shown, and this is the symbol of buzzer. So one terminal of buzzer is connected to VCC, that is positive terminal, and the other terminal is connected to port P1.0 through this transistor. Transistor is used to provide sufficient current to buzzer. So when this port terminal is 1, The transistor will enter into saturation region. Current will flow through this buzzer, through this transistor to ground. So since current will flow through this buzzer will generate a sound. So it will turn on. When we send here logic 0, transistor is off. So current cannot flow through this buzzer and buzzer turns off. Same program which we have written for a relay can be used for the buzzer. We have to send logic 1 at P1.0 to turn buzzer on and send logic 0 at P1.0 to switch this buzzer off. Passive infrared sensor is often referred as pyroelectric sensor, IR motion sensor. They measure the amount of infrared energy radiated by objects in front of it. They do not emit any kind of radiation, but they sense the infrared waves emitted or reflected by objects. The heart of this PIR sensor is a solid state sensor or an array of such sensors constructed from pyroelectric materials. This pyroelectric material is material by which it generates energy when exposed to radiation. Gallium nitride is most common material used for constructing PIR sensor. Suitable lenses are mounted at the front of the sensor to focus the incoming radiation to the sensor face. Whenever an object or human passes across the sensor, the intensity of the incoming radiation with respect to the background changes and the energy generated by sensor also changes. The suitable signal conditioning circuit converts the energy change to a suitable voltage output. Output of PIR sensor module will be high when there is a motion and it will be low when there is no motion. So these sensors are widely used in motion detecting devices. As an example, this is the number of one of the PIR sensor DSN FIR 800. It sends the motion used to detect whether a human has moved in or out of the sensor's range. They are small, inexpensive, low power, easy to use and do not wear out. They operate from 4.5 to 5 volt supply and the standby current is less than 60 microampere. The output voltage of this PIR sensor will be 3.3 volt when motion is detected and 0 volt when there is no motion. The sensing angle cone is 110 degree and sensing range is 7 meters. So if the motion is detected within this range, then output of the sensor will be at logic 1. The default delay time is 5 seconds. There are two preset registers on the sensor module. Here we can see the delay time adjust preset and the sensitivity adjust preset. So using this presets we can change the delay time and sensitivity. This is the interfacing diagram of PIR sensor with 8051 microcontroller. So it has 3 terminal, one is ground, one is VCC and third terminal is output terminal. So value of this at this terminal will be logic 1 when motion is detected, and it will be logic 0 when there is no motion. So when motion is detected, this 1 is connected to this transistor. Transistor turns on and current will flow through this transistor, and this port terminal will be connected to ground. So we'll get a 0 at P0.0. So as per this interfacing diagram, when motion is detected, P0.0 terminal will be at logic 0. This transistor is used to adjust this voltage level up to 5 volt. So here we'll write a program such that if motion is detected, then we'll turn this LED on. And if there is no motion, this LED should turn off. So PIR sensor output is connected to P0.0 and LED is connected to P1.0. So let us write the assembly language program to interface this PIR sensor. Here the assembler directive is used, that is EQU, equivalent. So we'll use the letters PIR for port terminal P0.0 and we use the letter LED for port terminal P1.0. So whenever we want to write P0.0 in the program, we'll use PIR, and for P1.0 we'll use LED. So we'll start writing a program from address location 0000H. First we'll clear LED. So P1.0 is at logic 0. So LED turns off. So initially we'll turn off the LED and then we'll set this PIR bit, that is P0.0, because we are using this terminal as an input terminal. So whenever we are using a port terminal as an input terminal, first we have to write logic 1 at that port terminal. This is for protection of this port. Then we'll continuously check whether there is any motion or not. So for that we'll use here instruction JB. If bit is 1, then we'll continuously check it. We'll continuously execute this loop if P0.0 is 1. If it is 0, it indicates that there is a motion, so it will come out of the loop. So if there is a motion, we'll turn LED off. After turning LED on, we'll check whether motion is still there or there is no motion. If it is 0, if PIR bit is 0, it will continuously execute this loop and LED is on. But if it is 1, P0.0 is 1, that means now there is no motion, so we'll turn LED off. So this is simple program to interface PIR sensor with 8051 microcontroller. And if we want to execute this program continuously, here sjump instruction is written. So it will continuously execute these instructions.